So how does this help us figure out what lasers are? Okay, so do you see this picture that I have just drawn? If this was light, what do you think you need on both sides to reflect? Mirrors. There we go, right? So the same picture, when you think about light, requires mirrors for it to happen. Good? Standing waves will be created just like any other normal wave. And the fact that there's a bunch of math behind it, and if anybody's interested, you can come look at it. But the E net, just like we did here, will be the sum of E1 and E2 with cosines. And if you remember, cosine of A plus cosine of A plus B is cosine squared A, cosine squared B, things like that. Let me just give you the gist of it. So the E net, or the resultant E, will be given by 2 E0 amplitudes, provided, remember we said that the reflected amplitude must equal the incident amplitude. So may I replace the E01 and E02 from here as E0? Okay, so that's what I've done. 2E0 sine of kx cosine of omega t. And in textbooks, what you will see written is this one is all depending on x, and this part depends on time. So may I write this as ax cosine of omega t? And that's what you will see written in a lot of places. Where ax is called the spatial dependence, and time is what varies. So keeping this in mind, there are two situations. One for nodes and one for antinodes. What did I say about nodes? That amplitude was 0. And for antinodes, the amplitude is maximum. Okay, so when amplitude is 0, may I write A of x equals 0, which means A of x, I defined it as 2E0 sine of kx. When is sine of kx 0? 0, 180, and so on, right? 0 pi, 2 pi, and so on. So here's what I'm going to do. 2E0 sine of kx. Is 2 equal 0 ever? Is E0 0? What's the only possibility? Yeah, well, if E0 0, then we don't have a wave. What's the only possibility? That sine of kx must be 0. And may I write that situation as sine of kx equals sine of m pi, where m is an integer. So it could be, when it's 0, sine of 0 is 0. When it's 1, sine of pi is 0. When it's 2 pi, sine of 2 pi is, there we go, right? So can I write this general formula as that? Which means I can rewrite this as kx equals m pi and 2 pi over lambda x equals m pi, or generalizing it to say m lambda over 2 is my condition for nodes. In other words, nodes in a standing wave are separated by lambda over 2. Or if I was to draw my standing wave, what is this distance? Lambda over 2. What is this distance? That's lambda. So in our standing waves, nodes are separated by lambda over 2. Okay, now what about for antinodes? Antinodes are places where amplitude is maximum. And I can tell you that this situation happens for all points when cosine of omega t is plus minus 1. And when is cosine of omega t 1? Good. And what point is it minus 1? Pi. What point is it again plus 1? Exactly, right? So may I write this as cosine of omega t for this condition to be true as cosine of 2 pi, or cosine of omega t equals cosine of m pi? May I rewrite this as omega t equals 2 pi? May I rewrite this situation as omega t equals m pi? What is omega? 2 pi f. T equals m pi. Or t equals m over 2f. And I can rewrite this as t equals 2 pi over omega.